Welcome, everyone. I'm so excited that we've got almost 100 participants at this stream. My name is Marcin Kosiński. I'm the founder of YR Foundation, and today I have the pleasure to be the host of this webinar. This is the first of the planned series of webinars. You can see all the other scheduled webinars on our channel. There are 3 that are already scheduled, and we've got a few others in our backlog. Today we will have a fascinating speech by Achim Zeileis, who is a professor of statistics at the Faculty of Economics and Statistics at the University of Innsbruck. He was an R user since version 0.64, and he's a co-author of the variety of CRAN packages such as Zoo, colorspace, or Partykit, Sandwich, or Exams. In the R community, he's an active ordinary member of the R Foundation, co-creator of the user conference series, and the co-editor-in-chief of the open access Journal of Statistical Software. And the talk will take roughly 45 minutes, and we'll have 10 minutes for questions. You are able to write on the live chat if you are logged on your desktop or through your mobile application. Enough of the announcements, and we would normally welcome Achim with a warm applause. And Achim, the floor is yours. I'm going void, and good luck and enjoy the webinar.
Thank you very much, Marcin, and for the invitation, for setting this up, and thank you everyone for joining me here. This is for me also a first experience, and from the chat I've already seen for a few of you as well. So I hope I can tell you a little bit about this R exams project we've been working on over the last years. So let me switch to my slides. Okay, so this R exams project intends to be a one-for-all exams generator. The idea is to have one pool of dynamic exercises, so we can leverage the power of R for generating randomized versions of similar exercise templates, and then deploy them in various ways. So we can use them for e-learning, and so the photo we see here on the introductory slide is an online test scenario which is conducted in class, and if you look precisely you can see that all the people have a similar exercise open. It's one with box plots, but it's all of them have slightly different versions of the exercise. And this would be one scenario which we want to support. This is another scenario that we will not be carrying out for some time now, but that is usually part of my job, that we have large lecture exams with hundreds or even thousands of participants conducted in a big sports hall in our case. And yeah, in order to leverage all this, we have dynamic exercises, and we use Knitr and SWeave to create these exercises, and then can deploy them either in e-learning environments, or in PDF form, or in a couple of other formats. And so it's really the same exercise, having rendered here in Moodle, in a live voting app called Asnova, and in a classical written exam. So the starting point for us to work on this was that we, like many others, presumably of you, regularly teach large lecture courses, also as support for other fields. So we're teaching mathematics and statistics courses for business and economics students, but there are similar challenges in social sciences, psychology, and so on. So the scale at which we operate at WU Wien, where I was before, and now at Uni Innsbruck, where I'm working currently, is that we have these large introductory courses attended by up to 1,000 students or even more per semester. And then it's not just one professor or one lecturer teaching this course, but it's actually several lecturers that teach the main lectures and also tutorial sessions in parallel. So we need structured materials, scalable materials to support all of this. And yeah, in the situation we are all currently in, there's also a great need to do distance learning, so to convert all the things you've been doing in class, in the university, to formats you can deploy over the web. And at least we in Innsbruck, and I know many of you as well, have in particular been leveraging the e-learning tools and the learning management systems that our universities provide anyways, typically at least, most universities do, and somehow get more out of that in this difficult situation that we are all in. So the goal that we set ourselves and that we gradually approached, I would say, or keep on approaching, is that we in these big courses, we want to offer an individualized organization of the whole learning, feedback, and assessment process, to be as flexible as possible, to react to students with different backgrounds coming into our classes, into different kinds of courses. So, for example, we might have evening courses or courses for students that are doing that while they're also working in a regular job. And yeah, now we're also doing that in purely e-learning based formats. And the core idea for all of what I'm showing you today is that we will have the same pool of exercises at the core of everything we do in the course. So the same exercises appear in the learning phase, in the feedback phase, and then in the assessment phase. And this flexibility that we've built up using our package comes now in very handy, because we can replace certain in-class materials by corresponding e-learning materials. And not everything works one by one, but by and large, I have the feeling that my courses are going all right. Of course, there are certain things you cannot replace, the personal contact, the direct interaction that you do in class, but you can there are also opportunities in this. So this is the setup we usually use in our big courses. So for learning and feedback and assessment, we offer both synchronous and asynchronous contents. So the main lecture is usually done synchronously in a large lecture room in the university, but we've always been live streaming it as well. And the main difference is that I don't go to university anymore, but I do the live stream from home. And we're using, unfortunately, Adobe Connect. Many of you are using Zoom or similar tools. So this classical lecture has been replaced, but the live stream is still very similar to what it always was when I was teaching from the lecture room. And the asynchronous formats are also the classical textbook, and we also have produced screencasts. And we had already done that in previous years, so this is also something that comes in handy now. Okay, but the learning phase is pretty normal, I would say, and the feedback and the assessment is now where our exams comes into play. Usually in my live lecture, I've been using a live quiz app called Osnova, And for asynchronous feedback without an assessment situation, we offered self-tests carried out in our learning management system and supported that by an online forum as well. And then for assessment, we have a formative phase that is done asynchronously through online tests over several days in the learning management system. And then we have a summative written exam. So this is what we did up to now. And so these, the synchronous formats, these don't work in the current situation for us. So we're replacing everything with things done in our learning management system. So we have still our asynchronous online tests where students have exercises that they can solve over several days, and they can talk to each other. They can use our forum. We can help them. It's really a formative thing, not a summative thing. And also, these online tests we are using now during the sessions, during the tutorial sessions, are intended to be formative. So students are logged into the learning management system and work on these online tests, and they're at the same time logged into Adobe Connect, into our virtual classroom, and they can ask questions there, they can discuss with each other, and they can discuss with us. And then this will be the most challenging part, the final summative assessment that we will do in an online exam, and we're not there yet. So we'll for sure, or almost for sure, we'll do it via the learning management system, but it's not clear whether we will use any online proctoring tools that students have to turn on the video camera or something like that. We still have to sort out that. I can tell you maybe more in 6 or 7 weeks. Okay, so coming back to our main topic, our exams. So all of these materials are generated from the same pool of randomized dynamic exercises that we build up over the years. And for feedback, these also support the complete individualized solution. So for every random replication, we really get the corresponding correct solution. And then we have the flexibility to automatically render this into different assessment formats, from online tests over written exams to live quizzes. And yeah, the package is called exams. It's on CRAN, has been there for over a decade now, but over the years grew very much in functionality. The core design principle is each exercise is a single file, either in our Markdown format or in our LaTeX format. And these files contain the question, this is mandatory, and optionally also the corresponding solution. This is not strictly necessary. So for a written exam, this might not be that important, but for automatic feedback in an online quiz, this is a very nice feature. And yeah, the files contain R code that is used for the randomization. And then essentially, you can do everything you can do in R Markdown or in SWIF files. You can include images, you can include R output, and if you're using learning management systems, you can also embed data sets and things like that. The answer types our exercises support are the classical single choice and multiple choice, and this is also the question format that is really supported by every system we interface with. Then we also have numeric values where the result is one number that you have to enter, a test statistic, for example, or a coefficient, or some number you compute from something else. We could also have text strings that have to be matched exactly. So these are typically short. And we can also combine several of these answer types in a single file, and this is then called a close exercise. And we'll see a couple of examples for this in a moment. The output we can create is a PDF. We have a fully customizable format where you can just provide your own templates and create your own look for the exam as you want it. But we also have a standardized format for single and multiple choice questions that can be automatically scanned and evaluated, all within R. HTML is possible, and this is also important for embedding the exercises into these learning management formats like Moodle XML or this question and test interoperability XML standard that is used by Canvas or OpenOLAT. This is the system that our university is using, an open source system that originated at the University of Zurich. Blackboard is supported, Ars Nova, TC Exam, and a few other things. And to make this all possible, we have created this package, but in fact, we're standing on the shoulders of lots of really cool open source projects. Of course, we're using R for all the statistical computation and for tying everything together. We're using LaTeX and Markdown for the text formatting and the mathematical notation. We're leveraging Knitr, our Markdown, and SWeave to dynamically tie everything together, have document conversion to HTML and also to other formats like Word documents, image manipulation, web technologies, and then all these learning management systems that we support. So we really try to provide the glue to put this all together and to provide convenient workflows, at least convenient to us or the users we know about. And I said the core of everything are the dynamic exercises, either in our Markdown or our LaTeX format, where we might have random data generation, we might not have. We have for sure a question, optionally a solution, and we need to have the meta information that we tell R and later on the learning management systems, for example, what is the correct solution and what's the tolerance for the numerical solutions and so on. And to give you a feeling for what this looks like, I'm showing you two relatively simple examples. The first one is in our Markdown format. It's a multiple choice knowledge quiz question with shuffled answer alternatives. And the second one is using SWeave formats, and it's a dynamic numeric exercise where you have to compute a certain derivative. But let's go through these one by one. So the question I'm asking is, which of the following cities are the capital of the corresponding country? And then I want to show participants of the quiz a list of answer alternatives. And to code that in this R Markdown format, we create a question. So in this question section, we simply write the question. And within the question, we need to have an answer list, or you can also call this question list if you want. And then we have an itemized list of big cities and the corresponding countries. And some of these are capitals and some of these are not. Then we also provide the solution. This is again a section in Markdown format with containing the corresponding answer list. You could call this also solution list if you want. And then I provide here some brief feedback on each of the answer alternatives. And you see some of the listed cities were not the capital, and then I'm listing the correct capital, and for the others I'm confirming, yeah, this was the capital. And but what I write here, that's important, is completely optional. It's something I can provide as feedback, but it's not processed in the meta information. So especially this true and false information is not what I use to tell the system which is the which of these is the correct answer, or one of the correct answers. So if I wanted to, I could also omit the entire thing if I wanted to do that. And so finally, we have the meta information, again, in a separate markdown section. We provide a short name. This is just for internal purposes. This is nothing the students ever see. Then we need to provide the type. Here, I'm using a multiple choice exercise called M-choice in exams. And then this is the important bit to tell the system which of the listed alternatives is correct and which is incorrect. And we have zeros for the false and ones for the true answers. And in fact, I'm not always showing all of the alternatives, but I'm telling the system to randomly select 5 of the alternatives. So when generating a new version of this exercise, it will draw without replacement 5 of these, I think 11 answer alternatives. It will make sure that there's at least one correct and at least one incorrect, because I'm offering both correct and incorrect choices, but it will select 5 of these. So this is a really cheap way of getting some randomization in the question without having to do any coding in R yourself. And this is all done by the exams package later on. Okay, so this is a multiple choice question. If I wanted to do a single choice question out of this, I would replace simply this M choice by S choice, and write here instead of R is. And then I could use the same exercise as before, and then the system would know it just needs to select 1 of the true answers, and the remaining 4 are sampled from the false answers, and then I get a single choice question where just 1 of the answer alternatives is correct. Okay, then let's move on to the next exercise. This is now an exercise in R and W formats, so mixing R and LaTeX. The question is, what is the derivative of f of x, where x to the a, e to the b times x should be, so you should compute the derivative and then evaluate it at a certain x equal to c. And then these a, b, and c are randomly selected in the exercise. So what does this look like? So the first part of this R&W file is a code chunk. And at first, I'm sampling A, B, and C. And here I'm using a simple sample from relatively easy sequences. And then based on the A, B, and C, I compute the correct solution. And here you see I have computed the correct derivative by hand. Of course, I could also try to leverage a symbolic derivation in R, but we're not doing that because we need the step-by-step solution anyway. You'll see that in a moment. So having defined these variables in the R chunks, I can now do my question. And rather than having a markdown section, I'm now having a LaTeX environment with begin question and end question, and I'm inserting these variables here with \s expression. Of course, it will also be possible to do the same thing in an R markdown file with the usual backtick R, A, backtick notation. Then you can also put it into an RMD file. The solution then, in principle, does the same thing. It just becomes more involved because I really write down the entire correct solution and always insert the right variables in the right places to finally get to the correct result. And then I have a meta information section that is now in latex style, where I say this is a numeric exercise. I insert the correct result formatted to a certain precision, and we allow a certain tolerance for the correct result. And I'll show you in a moment what this looks like in the learning management system. Okay, so to wrap up, what are the kind of questions we support? We have single choice questions, like the knowledge quiz question we see here. We could also have a single choice version of this derivative exercise where the distractors are either random numbers or typical arithmetic mistakes the students might make. Then we can have multiple choice questions like the one I just showed you here with 5 sampled alternatives. Or multiple choice is also a nice format for doing interpretation questions. So you can show students 2 box plots and then make several statements which are either approximately true or clearly wrong. And students have to tick the approximately true statements. And then we can have numeric exercises. Here we have a system of linear equations that has to be solved and a result computed using some funny clip art. And then we could have string questions where the answer is a short string that if you want to evaluate it, automatically has to be matched exactly. So you might, for example, ask for a certain R function, for example, and then students have to answer that. And then we can have these close questions, which might have first a single choice or multiple choice part, and then also a numeric part. And these are also supported. And one example would be this, where we provide a data set for download, and then we offer the students the choice. They should run a regression and say, is the correlation significant? Yes, no, and if yes, positive or negative, and then they should compute the slope, for example. Okay, so this is the core of the system, and also this is where your work goes if you want to adopt our exams for your own courses. You have to put in the clever ideas and good coding into getting good questions, especially that are robust over randomization. And then our exams comes into play and can render this into Moodle or Osnova or a written exam. And yeah, we provide different types of standalone files. You can produce PDF, HTML, docx, or you can interface with learning management systems. All you have to do is you have to define an exam, and an exam is just a list of exercises. Here, I'm defining an exam with 3 exercises. So I have 1, 2, 3 exercises. The first one is always the capitals question. The second one is a derivative question. And the third one is sampled randomly. It's either the box plots question or the t-test question. You can mix the Markdown and the SWIF format. That's no problem. So you have different ways of adding randomization. So you can add randomization by sampling between different exercise templates, or you can add randomization by including flexible R code within the exercise. And then we have various exams to something functions, exams to XYZ. And there's exams to Moodle, exams to Ars Nova, exams to Canvas, and so on. And I always provide as the first argument the list with my exercise questions. Then I provide the number of random replications I want to generate and an output directory. And the exams to Moodle then produces an XML file that can be imported into Moodle. And the exams to Ars Nova can produce something that can either be imported into Ars Nova, or we can use the REST interface of Ars Nova and directly import it into the running system. NOPS is our written exams format that can be evaluated automatically. I'll show you more about that in just a moment. And then there are other interfaces like that. Okay, so the first thing we want to see more of now is Elearn. I already said quite a bit about the goals, what we want to do. So we want to leverage our university's learning management system. In our case, that's OpenOLAT, and we can use that in different scenarios. So this would be an in-class scenario for a short quiz, or possibly after a collaboration phase in class, or an e-exam that is really the summative assessment. But of course, it's also possible to not only use this in class, but to do it remotely and we like to use these online tests that are conducted over several days. So we upload a set of questions, and then students can work on the questions for several days. All of them get randomized results, so they cannot just copy results from each other, so that only one does the exercise and the others can copy. But every exercise is a little bit different. And we actually encourage students to help each other. So to sit down in front of the computer together, or now to do it via video conferencing systems together, and to learn about the random variations the others have to tackle, and yeah, to discuss in a forum to help each other out. And this is quite nice in the formative phase of the course. Yeah, the creation you have already seen, this exams to Moodle or exams to OpenOLAT function. And after that, I just import the result into the learning management system. And from there, I do whatever is necessary in the corresponding learning management system. So I'll try to stop sharing this screen and go to our learning management system. And here I've opened one of these e-learning exams, and you can see now the different exercise formats. So this is a question about the capital or de facto capital of Switzerland, which is Bern, and so I can save this, and then I could enter the derivative here. I don't know what this is, or I'm not bothering to do this now. And because I entered the wrong result, the system now gives me automatic feedback, and I get my completely individualized solution showing me how to get to the correct result. And then we could have output with questions with our output in there. Here we have a question about the 2-sample t-tests. The test statistic is not larger than 1.96. We had a 2-sided alternative. The p-value is larger than 0.05, and this means we cannot show anything. And then we have here this box plots exercise where we have these statements that are either approximately correct or clearly wrong. So we clearly have not the same location. There are no outliers. The spread in A is clearly bigger than in B. The skewness is similar. Both are essentially symmetric, and B is not right skewed. So we also save this answer. Oh, I did some mistake somewhere. So apologies. I didn't tick the skewness is similar. I said I would want to tick it, but I didn't. Okay, and then we can have this question about the function. And the last exercise I want to show you is this one. This is the close exercise, where I can, if I click on this, it asks me whether I want to download this data set, or I can directly import it into RStudio, for example, and then run a linear regression of y on x as provided by this data set. And now I'm guessing here, and I'm saying they're not correlated, and the slope is approximately 0.1. But I was incorrect, and here I see the correct result. Okay, and then I can at some point finish the tests and close it, and then I would get feedback about the points I received and so on. So students can do this in their own time, either with self-tests or with formative online tests in our case. Okay, let me switch back to my slides. Yeah, I've got some screenshots here, so you can do this in Moodle, you can do it in OLED, or you can do it in this live voting software we like to use in our classrooms called AskNova. That is also a really nice open source tool if you're not familiar with it. Then written exams, which I'm not going to say that much about today, because it will be a couple of months probably before we can do such large written exams again. But yeah, we have these flexible formats with exams to PDF and exams to Pandoc, where you can provide your own template and roll your own format, but then also evaluate it yourself. And we have the standardized NOPS format, where you get these standardized answer sheets, and then students can tick their answers, and then we can you can put these on a scanner and evaluate them in R afterwards. So the process for these written exams is that with exams to NOPS, you can generate the PDF files and the correct meta information. Then you print out the exams either on a sufficiently fast printer, or you're bringing it to your printer shop. Then you conduct the exam, typically in class, collect just the exam sheets, put them on your scanner again, and with the result, be it in PNG or PDF format, you can then use functions NOPS scan and NOPS eval to evaluate the results all in R. And then you get an HTML report that you can send back to the students with their individual results. And these look like this. So every student gets his or her result, can see which exercise was correct, partially correct or wrong. You also get the scanned sheet. And we have this entire system in some 20-something languages now. So many languages are already supported. Okay, looking at my time, I'm almost running out of time, but I'll still take a couple of minutes to fill you in what you should do if you want to try this thing out. Especially if you want really not only want to try this thing out for yourself, but you want to try this out in class, maybe this semester even. So the The first recommendation is start simple. One problem I often see is that users of our package come with very specific exams in mind, because this is the way they've been doing it for years in other systems, and then they want to convert it one-to-one. And often this is possible, but might create more work. And it's not so much fun to start with that. So I would recommend start with simple exercises, maybe not do everything through these exercises, but produce a couple of exercises as an additional online test, for example, and keep it simple. Focus on the content of the exercises. Don't worry too much about layout and formatting and such things. Especially those that have very nicely formatted LaTeX exams. I would recommend emotionally stabilize that your exams might look a little bit different now. It also helps to build a team with lecturers, student assistants, and so on. This is particularly useful for quality control also. I can write an exercise and then send it to my colleague, and then he or she can have a look and give me feedback. And so we have more confidence before putting something into a course. Be creative about using the exercise types. There's quite a lot you can put into multiple choice exercises or into numeric exercises or these cloze exercises if you have good ideas. And this is what lecturers are typically really good at, having good ideas about exercises that give feedback or that are useful for assessments. I would also say don't be afraid to try stuff, especially in formative assessments. So I would be careful in summative assessments. So the big exam at the end of the course, I would be careful with introducing new stuff for that. But to say, well, we have an additional online test this week, and it's worth, I don't know, the online tests are worth 5% of the points you can collect over the entire course. Then this is enough to get at least our students interested. And it's not so bad that if something goes wrong, people are frustrated or start yelling at you. At least that's what it's like in our university. And if something goes wrong, which didn't happen often, but it did happen, of course, then I also said, okay, this exercise was wrong. We did a coding mistake. Everybody gets the point. And if this just happens for 1 out of 10 exercises or 1 out of 20 exercises, then the students are really fine with that. And before summative assessments, I would recommend some more thorough quality control. And here the team would also be important. Yeah, if you want to get started, I have put together on the slides some remarks. All of these also point to resources we have on our webpage. So I'll not go through these in all detail. Also, I should say the slides are available from my webpage. I'll also put them up on the R Exams webpage probably tomorrow. So you can go through the slides again. So you have to start installing all the infrastructure. A new feature I want to give a shout out to is TinyTech, that will be in the next release coming out maybe today or tomorrow. And this makes it super easy to install LaTeX on a system that doesn't have it yet. So all you need are these 2 lines of code and you're done. Fantastic work by Yihoi Shi, championing this topic again. So I look very much forward to having this on CRAN. Then, if you want to start playing around, you can call the exam skeleton function, which creates a number of demo R scripts, folders with exercises, templates you can look at. And you can also go through the first steps tutorial on our webpage that explains a little bit more about this. Then you can try to compile the built-in exercises. I would always start with exams to HTML and exams to PDF to see whether the basic conversion essentially works. With mathematical content, we have different mathematical renderers, so you can try out these. And you can also check the corresponding meta information. This is important before putting something into a learning management system. Then we have a nice tool, a stress tester, that generates many random variations of an exercise and tries to look for errors, warnings, long computation times, systematic patterns in your solutions that students might pick up, and then have shortcuts in your exam. And there's also a tutorial for that. I'm skipping that here, essentially. So let me wrap up. I hope I've given you a good overview of what this R exams package is about. And while I'm the lead developer, I'm by no means the only contributor to this package. Over the years, quite a few people have done some bigger, some smaller contributions, but all very useful and very important. So credits also to all of them. Where can you find more information? The first starting point is the rexams.org webpage, where we have these tutorials, links to documentation, all the exercise templates we have built into the package with some explanations. It is on CRAN, currently still 2.3.4, hopefully 2.3.5 later on today or tomorrow. The package is developed on RForge because it's already quite old, and we've been using RForge for now 15 years or so in the development and are still doing so. We have a forum there. Feel free to ask questions there. I'm also watching on Stack Overflow, so feel free to ask questions on Stack Overflow, or if you want to discuss something, announce things publicly about our exams, you can also do so on Twitter and add me to that. There are also 2 scientific publications if you want to cite this formally in a place, but the information is already a little bit older, so a lot has happened in the last 6 years. So this is not the most up-to-date reference anymore. But for citation, it's still very much appreciated if you cite it. Okay, that's it from me, and I'm very much looking forward to hearing from you if there are questions. But for now, I'm saying thank you very much.
Thanks, Achim. That was a very interesting presentation. Just to let you know, we had 100 participants during all the talks, so you keep them entertained, and I'm really grateful for your energy and time that you invested in this webinar. We've got few. I'm happy you also enjoyed the webinar. We've got few questions that were posted over the stream. You have already answered to one was related to whether this can be used with Moodle, integrated with Moodle, but it looks like you can do that. The other one was
something about. May I add something? Moodle is a really nice and powerful system, so with the exams to Moodle, you can export all of these exercise types I've shown you in OLED. You can also export these to Moodle, and I've just posted a video tutorial on YouTube that is also linked on the R exams webpage that takes you through the process step by step, from the point where you've used R exams to create the XML file to the finished tests in Moodle, going through the question bank and everything. So you should have all the information you need for that in the video tutorial.
Amazing, amazing. There are so many resources and tutorials, and personally, I loved the resources slide. You've got all the content in one place. Okay, let me have another question for you. Okay, have you ever had a proposition from the headhunting company to use R exams during R programmers' job interviews?
No, we didn't have that. I have had interactions with some people from commercial testing services that have been interested in the system, but yeah, these were always modest requests, so I help them like I help all other R exams users. And as for using them in R programming tasks, the question with that is what exactly you want to do. So you can, in these question types we have, of course, you can put programming questions in there, and I'm using that for my own programming exercises. But there are certain things you can not capture well that are important for programming that you can do in these really standardized tests you run in learning management systems. So in my own programming course, we're trying to play around with collaborative coding, that they post their code and I make comments and the other students make comments, and to make progress like that. But that doesn't really fit into this automatic feedback we're doing here. So for teaching R, you can leverage it, but you probably also need other resources as well.
Okay, makes sense, makes sense. Okay, maybe next one. Have you considered using YAML files as an input? So it looks like you can make it language agnostic and use it in other languages. That's the full question.
So you can author the questions themselves in any language you like, and then the only structural elements we have in the Markdown are these headers where we say question and answer list and solution and meta information, and then we have our own tags like X solution and X type. So this is really minimal, and we don't have internationalization for that. So for if I want to create something for Moodle, for example, I just write the question in whatever language I want to use in Moodle. And for the written exams, where we have this standardized PDF output, we have a relatively simple text file that you can customize. It's about 30 or so small pieces of text that you need to translate into another language, and we already have some 25 or so languages from English to Japanese and Portuguese to Russian and so on. So look whether your language is already supported. If not, contributions are welcome.
Okay. I think this also could include the programming languages, not necessarily the speaking languages, but I see the application.
Programming languages is an interesting point. So if you want to do the randomization part of an exercise in Python, for example, rather than in R, I think this should be doable, because of course we stand on the shoulders of Knitr to process the R Markdown files, and Knitr has this capability. So I think this should work. I haven't tried it though. But it would be interesting. If anyone tries it and is successful, please reach out and let me know. This would be interesting.
Yeah, I see there's a space for a good start in a different language. Yeah, for sure. There's also a question about the utilization for surveys. Like, would this be useful when creating and filling the survey?
Yes, but the advantages over creating the survey in the system you want to use it with directly are not that big. So because when I'm doing a survey, I'm typically asking everybody exactly the same questions, and I don't need all this randomization. And then when I'm conducting a survey with my students, for example, sometimes I put together the questions in the survey in our exams and import the survey, like I do with an online test. And sometimes I just put together the questions in my learning management system directly with a point-and-click graphical user interface that the learning management system offers. But that's a matter of taste.
All right. Tell me if you still have energy. We've got a lot of questions going on. Like the next one is about integration with Shiny. Any ideas on how this could be integrated with Shiny? Any benefits of using Shiny?
So there are several ways you could think about combining this with Shiny. One way would be to have a very basic system for deploying the exam, so that I don't have to have a full-blown Moodle or OLED or Canvas system in which I can share my my questions, especially if these are self-tests. I don't mind if people can look into the code running in the background. And then it would be nice to have a very basic Shiny sheet I can export questions into. I haven't tried this out. Also, there were people asking about Learner, whether we can render our questions in Learner. And at the moment, we cannot, but this would be interesting. So if anyone plays around with this, let me know. I'm not planning on doing it myself, or anyone from our team is not doing this at the moment, but this would be an option. The other way that would be interesting to leverage Shiny would be as a graphical user interface for putting together an exam. And this is something we are currently working on. I have a student. I've hired a student that was doing quite well with previous Shiny-based tasks. And yeah, she has just started, and we don't have something to show yet, but we might have something in summer. We'll see if there is. I'll share it through the webpage.
Okay, this is very interesting. So it looks like another topic for another webinar.
Yeah.
Okay, thank you, Achim. There is a lot of thank yous and hugs on our chat. I think we have went through all the questions that were not answered through your talk. So I think we have reached the end. I'm really thankful.
And I'll also be on Twitter tonight. So if you want to ask follow-up questions that can be reasonably answered in 280 characters, I can try to tweet back. Or I mean, if there's a more complex question, file something on Stack Overflow or on our forum. That's also fine.
Yeah, and for this purpose, we also opened our Slack. You can guys join yr.pl/slack/ so that you can join our Slack, and there's a special room for the conversations related to webinars. And I hope you can also be there, ask any questions today or tomorrow.
If I can remember my Slack username and account, I'll be there. No, I'll try.
You will create a new one for this this special environment, so that's easy. Okay, thank you, Achim, once more, and thank you to all that survived till the end. And looking forward to the next webinars. The next one is happening on Thursday, 8 p.m. GMT +2, and we will have a talk by Olu Naldin, who's a senior data scientist at PwC, and we will have a talk about integration of Shiny in the mobile framework. Thanks for
you.
the talk, Achim.
Bye. Thanks.